We're here at the Bahia Yacht Club. Special event, AutoDesignO. What is AutoDesignO? It's some of the leading designers in the country looking at how they see the cars, what they look at, angles different, and how you're going to drive these cars in the future and what they're going to look like when you're putting wax on, wax off. Let's come inside and check out AutoDesignO.
Nurulize. It's on the screen if you haven't seen it. But if you haven't tried this, in the room next to us, this virtual reality experience is unbelievable. Most of you, I'm sure, have never tried virtual reality, and it is shockingly cool.
Yeah.
Yes, sir.
We did it, and it was the most unbelievable thing I've ever experienced.
The most unbelievable thing you've ever experienced. More than...
I can't get over the fact that I can see my hand. I feel like I'm still in there.
It's an amazing, lasting effect that it's going to be big.
So anyway, I was saying earlier, my prediction is everyone's going to remember their first virtual reality experience, and that was mine.
We always remember our first
time.
Yeah, that's right. That's right.
So tell me, Philip, you're, just to clarify for folks,
Yes.
Nurulize is the software maker.
Yes, we're a software developer developing applications specifically for virtual reality.
So we have hardware makers. Everyone read about Oculus Rift last year when it was acquired by Facebook.
That's right.
And made an instant millionaire out of a fellow Long Beach State graduate.
Yes.
Actually, he didn't even graduate. He was still a student.
That's right.
And here we are with what you're doing on the software side of this.
Right.
So why don't you tell us, just tell us about the product, tell us what you're doing, and let's get everyone salivating to go try it if they haven't already.
Well, I was one of those people that bought a Oculus Rift on the Kickstarter campaign when it first came out. I saw this thing called virtual reality. I'd actually never tried it in my life. I bought this Kickstarter. It arrived in my office. I put it on my head. I loaded up the standard scene. I looked at it a bit and I go, wow, I wonder if I can get a car in here. So I found a car model, imported a car model, put it in there next to this Italian villa, it was called, the demo. And then I brought a building in, and I put that to scale off into the distance. And I gasped. I had an emotional reaction to seeing, for the first time in my life, and being in the computer industry for the last 20-plus years, the first time I'd ever seen something to scale that I actually felt. I could feel this object in front of me. And it was just such a radical thing. I was in the process of selling my previous business, which was an automotive visualization software company. And I was compelled to start a new business. So as soon as I closed that deal, I started another company, and this one's focused on virtual reality.
And when you started this one, was the automotive industry a key target or the only target, or how would you say how the automotive part of this winds in?
I know a lot of folks in the auto business. I've been working with them for many, many years, so it's an obvious place to go back and get some more business with this new technology, so that was an easy thing for me. But the application we're actually building spans all industries. It can be used for construction, for design visualization, for resource planning. Let's say you're a concert promoter and you want to plan you're going to a new stadium you've never been to before, and you want to plan how you lay your cables. You can do that. You can collaborate with others. It's a remarkable thing.
So for those of you that haven't tried this yet next door, what we saw when we went in there is you put on the headset, and on the table is a little clay model of a car that now becomes 3D. So it's like there's nothing on the table there in actual at all. But as you walk around it, you're walking around a table in which you see the car from every side. Then you turn around behind you, and there's a full-size McLaren.
That's right. Yeah.
Sitting on the floor right behind you. You can walk up to it. You can put your hand against the headlight. You couldn't honk the horn, I noticed.
Not yet.
There's a little fence that doesn't allow you to go outside that area. But it is a surreal experience considering you're in an empty room, and you look like a complete fool to anyone else that sees you doing this, but you're in your own
You don't
world.
care. That's one of the interesting things about putting one of these headsets on is you completely lose sense of where you are and who's looking at you and who else is in the room. You're in another world. There's been much discussion. If you think about what the human is, we're just a receiver of external inputs. We process those with electrical signals, and it makes it into our reality that we are sitting here today. We have light coming in, and we're processing in that. By replacing those signals in the exact same way that we're receiving them now. Your brain receives that signal in the virtual space as it would in real. There is no difference to reality. You feel like you are there. And it's something that requires a couple of very difficult technical things. One, it needs to be 90 frames per second per eye. So if any of you play video games or understand the video game world, 60 frames per second for a single 1920 by 1080, that's, you have to have that. Now we're talking about 90 frames per second times 2. So the processing power required for this is significant, but the graphic card companies are handling this and taking care of that element for us. So we don't even have to worry about that. But if you have that 90 frames per second, when you shake your head or move around, your brain is keeping up with what you're seeing, and it feels real.
So let's talk about how this would be used in the auto space, in the auto design space.
Right. So there's
Where
many.
where do you see the real value here? How would this pay off for a company like Mazda or Toyota or General Motors that has design studios around the world?
There's obviously many immediate payoffs. The application that we're developing is called Atom View, and what Atom View does is it enables you to visualize point cloud scan data. So you can take a LiDAR scan or a white light scanner that they use in the studios to scan a clay model that might be full size or scale. Scan that, we import that data, now it's in your virtual space. Now you take a CATIA model of a steering wheel or a grill or a wheel or whatever element you're working on, you can now render that into points just like the scan, so we have a format that's consistent. It's as simple as rendering an image. You open up the CAD model, you put a shader on it, you hit render, it creates a three-dimensional point cloud of that part. And then put that in the position over the clay, and then put the headset on, and you can then visualize that part on the clay model physically as it would be to scale.
So this sounds a little bit like what they're doing in movies now, where they have, if they're going to do a CG version of a scene, they put on a bodysuit that has a series of points on it.
Right.
And that's what they use for the motion in the computer.
Right.
Same idea with the LiDAR. This almost takes points of a design object.
Kind of. Interestingly, that technology of motion capture is what those two little, what they're called lighthouse stands are doing. They fill the room with lasers. Your headset is tracking you in positionally accurate. So essentially, that's a motion capture system that you're wearing. It's not a suit, but it's tracking your head, and you have two hand controllers. The laser, what that does is it does a static scan. So it's like a 360 camera. Some of you might be familiar with those. You put it on a tripod, you hit go, and it slowly scans the room, sends out a laser beam to everywhere, and then creates, wherever it intersects with an object, it captures the distance and the color with very high precision. You take that point, which is now a big cloud of points, and then load that up into Atom View, and we call it Atom View because it's, little tiny points is really what we all are. And we have an algorithm that elegantly scales those points, so no matter how close you get to them, the object seems solid. So you feel like you're in this solid geometry world that has never been possible before.
So the way you envision this is, in most cases, they would start with a real-world physical object, like a clay model.
That's for the car design business. You could start with the clay model. You can start with an all-digital model. We work in either or. It's not limited to just physical. It's not limited to digital. We can take all scan data. We can take all digital data, or we can take elements of the two and combine them together.
And the beautiful thing is, as you pointed out, then you could start attaching parts to it. You want to add a spoiler, see what that would look like? Add a digital spoiler.
Exactly, and switch it off and change it out very rapidly. And in addition to that, it's collaborative, so you can have a second person who's maybe in Japan come into that space with you. All you do is share the file on a server. They download the file, they have it on their machine, you have it on your machine, and then a connection goes between the two, much like a network game. I see you, you see me, we talk to each other over a microphone, and it's like being in the room with them. So it's sharing it's like sharing a physical virtual space, if that.
So in a world where a large automaker typically has 5 or 6 different design studios all over the world, conceivably, several of those designers in different places could be online at the same moment looking at the same object.
Exactly, just like a teleconference where you might do a web conference or you might do a video conference. The difference is you're inside that space in the 3D space, and you can say, hey, come look over here, look at the side down here, this is what I'm talking about, come over here. And then that person can stand actually next to you, pointing and looking at something.
Now, you wouldn't know that person standing next to you, would you? It would only be you and the car.
You would see
the other collaborative people on the line.
You'll see an avatar.
Okay.
So it would be a representation of a body and a head. and that head will move and nod as you would expect it would. And in all, your brain says, yes, that person is sitting right next to me or standing right next to me. You would feel that presence of that person.
So they could say, come look at the design, come over here to the right side of the car and look at the design of this door handle.
Yes, exactly.
And you'd both be standing there.
That's right.
The avatar would.
Yes.
Could one of you say, you can't make anything work with this. You can't open the door.
Well, if it could be programmed to open, right? So it has to have some programming element to make it open, but you certainly can pin a note, you can, and we're already conceptualizing how we're going to be able to draw a line on top of that, on that virtual model as well.
What do you mean by that? Draw a line on top of that virtual model?
Sketch on it.
Uh-huh. So in other words, you could say, wouldn't this be better if we did this? And then you take a magic marker that works in 3D in middle of space.
Exactly.
And say, let's do this curve a little curvier.
Exactly. It's precisely it. And there's already an application that was purchased by Google. It's called Tilt Brush. We have it here. You should try it. Car designers go nuts for this. It allows you to paint and draw in 3D space. And anybody who's tried it, and I just had a bunch of guys in Detroit trying it, simply says, I will never use paper again after this. I'm done. No more paper.
Well, let's pick up on that. Yeah. How much do you think this product is going to revolutionize the auto design space?
I think it's going to completely revolutionize the automotive design space. I think finally there really is a link between the digital and the clay. And in the past it's been talked about for 20 years, but we all know that when you're looking at something on a flat monitor, and then when you mill it, there's a big disparity from what you think it is and what it actually is. And there's never been a connection there. I think that connection now, the line is going to be truly blurred because you can look at it in a digital space and see it for what it actually is with your own pair of eyes, with no nice 110 millimeter lens with a long shot that makes that back end look just exactly right. You don't have any of that. You will see it exactly as it is, as if it's sitting there in a physical form.
Some of us have been out. I know Honda has done this. Honda a few months ago had a few of us out, and we could sit in a theater and see how they crash test cars virtually, and how they could change a member, change the actual design of something in a matter of hours, and then virtually crash test the car again, and do that 20 times. And then they showed how they could take the same vehicle and crash test it in real world, and then put the two images side by side, and they were virtually identical. This sounds kind of similar to that.
It's very similar to that. I believe the first thing that car designers are actually going to do, we haven't got there yet because we're still so new and the software is yet unreleased, what their first thing they're going to do is have a physical model of a clay model, scan that model, take that scan into our software, and then align it so it's virtually right over the top of the physical. So you set up that rig we just see with the two cameras in the room with the clay. You overlay that digital model on top of the clay model, and then you reach out to be exactly where you think that model should be, and boom, you're going to touch the clay. But it looks like a nicely painted, finished model, but you're touching the clay. And as soon as someone does that a couple of times, they'll get the sense that, wow, this really is as accurate as I think it is. We can reduce the number of clays that we do.
And the advantage of that, though, is you like the tactile aspect of it. The reason to do it is so that you actually are touching something physical.
Right, it gives you a calibration. We've already talked about doing interiors as well. You know, you may have a seat which doesn't change maybe as often as maybe what the dashboard shape does. And, you know, and talking about the symmetry around all this, you can get a sense of that, but if you could reach out and actually touch the panel, maybe you know exactly where your LCD display is going to be within that clay. You can actually put that in the digital right there and have it function. We can feed a computer's output into that virtual window inside your virtual world. So you could pull up your HMD and your heads-up display and see an accurate representation of that in overlaid a physical model, which would be impossible to do and so early in the process.
So right now, as we know, clay models are really done to amazing precision. I mean, you can walk into a room sometimes and see a clay that is every square millimeter the car that will virtually result. It sounds to me like with this system, we're going to probably see clay models that are less representative of the actual car, maybe more like the camouflage version would look to the world, allowing them to play with all kinds of surfacing details. Am I right?
I think so. I think so. Absolutely. As soon as people just get a sense that, what I'm seeing is real. It does equate exactly to the physical. The virtual and the physical line up, and all this stuff is exceedingly precise. These laser scanners are, fractions of a millimeter precise, so they can, over a distance of 100 meters, it's sub-millimeter accuracy for that point in space. So they're highly accurate. They represent the tracking. If any of you have tried, well, as soon as you try this, you realize the tracking is dead nuts on. I mean, it is sub-millimeter accurate as well. And put those two together, and you have something that I think will enable that exact thing you're talking about.
So designers talk about the revolution in the last few years in design in terms of what they're able to do because of hydroforming, other techniques, shaping. We're able to get curves and surfaces and complex curves that we've never seen before. What do you think this will do, this technology could do to auto design in the future?
To me, it will simply cut time out of the process. It's going to enable you to iterate much more and do a much more design ideation earlier in the process. Be able to get to a much more clarity before you hit that milling button, which costs a lot of money.
Do you think if they save that much time, they may allow them to put more effort into the designs, which will become exponentially more detailed?
Well, you know how it is. You get a time budget, you use every second of it, right? So that's just a fact of life. So you means you'll be able to iterate a lot more in that same time budget. Or some boss guy will say, "Look, we're cutting the time budget. You now add 9 months. Now you got 7. Sorry, and you can now actually achieve what you need to achieve in the 7 months," which saves the money, right? That's what everyone's.
How much time do you think this process could save?
I think it could potentially be quite radical, actually.
Half?
It could be half. It could be more. I don't know. I mean, it's yet to be seen. There's going to be a lot of experimentation with this. But, we're at the point where, we're almost ready to let people start trying it in the field, right? So we're due to be in beta in November, and we're shipping in January. So
what are the challenges for you right now? Are there some last-minute things you're still trying to work out?
Well, I mean, there's a software you can have a list a mile long of what people want, and everybody says, "Well, I want this, and I want this, and I want this." But everything you do adds bugs, and I've been in the software development business for a long time.
What's an example of a couple things they want?
They want to be able to draw on the surface, right? They want to be able to collaborate, and they want to be able to see it, combine clay capture with a digital model from CATIA or ISOM or Alias or whatever product they're doing their modeling in.
But you mentioned to me that some of these automakers are dead on serious about that. They want it now. You mentioned to me one is already buying multiple cameras, like they're talking about buying 4 cameras.
Yes, there's a scanner called a Surphaser scanner. It's a very, very highly precise German-engineered piece of amazing equipment. And if you had a piece of paper on the wall, stuck to the wall, you can see the gap between the paper and the wall. It's that accurate. And they're already investing heavily in being able to capture these models that accurately. So that's already happening. So now we can actually use that data in a whole new way that they've never been able to before.
Philip, how competitive is this space? Do you have competitors out there?
Well, I've done some research on the scan data visualization market, and there's about 68 different applications that visualize scan data. And not one bit of that scares me at all, actually, because I did a bunch of check boxes, and we have 5 check boxes that no one else has. So we developed this from the ground up for VR, number one. It's a clean sheet of paper, a couple of very, very high levels, scientist level programmers have built this algorithm that allow us to do this. It's not an easy task to do, very difficult. And and we do some very unique things. Collaboration, no one does. Scan visualization at 90 hertz for VR, no one does. That's a big one in itself.
Give us a time frame.
January.
Release available to anyone needs.
Release available in January. Atom View will be all being, forces of goodness all fall upon me. It'll be ready in January. Yeah. So we're in beta in November.
And how much demand do you think you'll see?
Well, my guess is the early adopters will be, some of the car studios, but then there's every single scanner manufacturer, and then there's every single person that renders in 3D. We can take a CG object, and rather than render a flat image, we render a volume. So it's basically a volumetric rendering, and that volumetric rendering now becomes points, and you visualize the points in Atom View. So any CG element, any scan capture, across all markets. So it's a fairly significant potential here.
I'm not sure I'm understanding what you mean by volumetric. Yeah. What are you talking about?
Well, if any of you know that you have a computer-generated 3D scene, and typically your output of that is a rendering. You hit the button and it renders a picture. So now you have an image that you can put in your newspaper, right? Okay. So instead of rendering the image, we now have another button that's in the software that it says render to points. So now you're rendering that, not just a flat image, but you're rendering the entire object as a volume. So it has depth. You see the whole object, and then we bring the object in, put it to scale.
Now, is that the same thing we're talking about when we see the car sitting on the floor in the other room?
Exactly the same thing as seeing the car on the floor in the other room. You have a volume there. So you render that object to a volume, and we treat that data exactly the same way we treat the scan data. So combining the two together is effortless.
So the inevitable 5-year question. In 5 years, do you think this is going to be a must? Well,
I hope so.
I'm sure you do. How realistically, do you think this can catch on like wildfire, or is it going to be kind of a slow adoption thing?
No, I think it's going to catch on like wildfire. I think the only limiting factor we have is that you can't get it until you see it. So you have to put a headset on to really understand what we're talking about. If you haven't tried one of these VR headsets, you just like, okay, I could talk to you till I'm blue in the face and tell you how great it is, and I'm going to change the way you think about things completely, and it's going to blow your head up. But you won't believe me. You'll be like, okay, yeah, I've seen it all before. I tried virtual reality in 1997, and it made me puke. You know, I mean, that's, or I put this giant thing on at Disneyland, and it was awful, right? That's what everybody thinks about virtual reality. This will change your mind, and once you try it, you go, okay, now I get it. And the applications for this are immense. And that's, of course, what Mark Zuckerberg saw when he went to Oculus and saw the headset. He's like, this is it. This is going to change everything. And to me, it's a revolution in computing. And it's the biggest thing to happen since computing began.
It's dinner time, so let's talk about the puke factor. This was a huge challenge for the industry, right?
Yes,
I mean,
absolutely.
the problem
100%.
was, we talked about it earlier today, early sets
Yep.
were such that your body thought it was being poisoned.
That's right.
And we all know what happens when that happens.
You don't want to do it again.
And now they've overcome that on the hardware side.
Yes, the hardware is there, but it requires 90 frames per second, which is a very difficult to do in the software side. You need either a very powerful machine, or you need to have some of the tricks that we've learned to optimize your scene in order to enable it to.
So is
to
it
do
just as difficult on the software side?
It's a very big challenge on the software side, and that's why basically all existing software, if you think you're just going to make that work in virtual reality, it's not going to. You need a clean sheet of paper approach, which is what we did. I was one of the first, first purchasers of the Oculus Rift. I jumped on it right away. So we've been in business 2 years already working on this application.
So how did you know, you went into this with a high degree of confidence. You knew you could pull this off.
Yep.
Why?
Well, Moore's Law, basically, more than anything. I know I can wrangle smart programmers. I know I can get some smart people together who are a lot smarter than me. I've done that before. And I also know that Moore's Law exists. 2 years ago, the hardware wasn't really there, but we've had 2 iterations of graphic cards since then that have basically doubled the performance from 2 years ago. And that's going to just continue. There is no end in sight for that.
So in the development of this, which is a 2-year process?
It's been in development 2 years, yes.
Did you ever hit brick walls? You thought, there's no way we're going to overcome this?
No, I was confident we could do it before we started.
But you did hit some big walls.
Well, of course, we always hit walls in development of anything. You're developing a new car, new engine, new anything. You got some wall that's like, oh, I didn't think I was going to be able to do that. I think the biggest risk for us was, is it going to work? Can we actually make these points move around fast enough with this potentially a vast amount of data? Can we actually do it? So I guess there was a rolling the dice in that sense. Could it be done? And I just had blind faith that it could be done and we could figure it out. And the stars aligned. A programmer walked into our office that it was just like it was meant to be, and he was exactly the right guy who could actually make this happen. So it basically comes down to one individual programmer who did it. He's a genius.
John, how are we doing on time?
Well, I think we're almost there.
Okay.
Let's take a few questions. Right over here.
How does it compare to Autodesk Red?
Oculus Rift, it's just a different.
Autodesk Red.
VRED? Okay, VRED or VRED, yeah.
Can you tell us what that is first?
Yeah, Autodesk VRED is a design visualization software, right? So it's been around for probably 10 years, right? And it enables you to do a headset as well. But again, right? Have you felt nauseous at all doing that? No? Well, then you're lucky. You're one of the few that doesn't. So you've had 90 frames per second doing that.
We had at least a fast computer.
Okay, well, that is, in some sense, this does the same thing, But VRED doesn't do anything with points.
And do you do ray tracing?
We don't do anything with ray tracing. Nope. Everything we do is point cloud rendering.
So the reflections are,
At the moment, we don't support reflections. That will be in version 2. So
Help us. What's a reflection?
reflection is a live reflection we won't have in version 1.
What's that mean, though?
That means actually reflecting light accurately. But we do, what, I want to just add to that, we do take, if you've got a scene, let's say in Maya, that looks like a perfect rendering, you can render that perfect rendering into the scene. So it won't be dynamic, but you get a very, very high level of visualization that is impossible any other way, including VRED, not possible.
Let's dream a little further. You already have the data, you already have the system.
Yep.
Connect it to a 3D printer on both sides.
Of course, yeah, yeah, no problem.
So your point is?
The point is that you can actually then, whatever you rendered and walked around.
Yeah, yeah.
Printed is printed.
Yeah, if you draw a line or create something in there, you'll be able to print that. Yeah, absolutely.
In 3D.
Yeah, yeah, of course.
In 3D.
Can you wear glasses and does it hurt the experience at all?
You can wear glasses, no problem. It just fits right over the top.
I'm ready to try.
You should try it. I want everybody to try it. I mean, it takes some time for each person to see it, so we'll try and make it short. But if you just get a taste of it, you'll get an idea of what it does. Yes, sir.
What does it take for this to be adopted and then widely adopted? What's the next step?
Well, I mean, there's a lot of market projections. There's all kind of analyst projections on what's going to make adoption. The manufacturers of the headsets are targeting directly at the video game developers and the video game companies, right? The first experiences will be game guys who are playing Dota or Team Fortress or some other game. It's going to be a virtual reality version of that, and it's going to suck people in, and you won't see them again, right? So that's the first wave, and that's probably about 4 to 5 million people, right? I think that's right off the bat, they'll sell 4 to 5 million in 2016. And then after that, these people will have a system in their house. They'll invite their friends over. They say, hey, check this out. And they'll be like, holy crap, I got to have this, right? So they'll be buying one, and it'll just spread with word of mouth. I think, you know, and there'll be some educational experiences. There'll be experiences for your children that you'll have to have for your kids. Just like there's iPads apps that you're like, oh, you know, that's a pretty educational iPad app. I'll give that to my kid. It'll be like that for virtual reality. Oh, I think he wants to learn about the universe and go travel through space and understand the scale of the planets and everything. I'll let him look at that one. And that's how it'll be like, oh, you'll rationalize it for your children, and then who knows what's going to happen then. We'll all just be vegetables sitting in a pod with one of these headsets on, which I think is actually where the human condition is going to evolve to. I really do. I believe that's what's going to happen.
what kind of price point are we talking about?
Well, there's been no talk of pricing other than it will be $300 to maybe $700 for the hardware. So it's certainly not anything that's going to be a limitation, but it will require a new graphic card. I can tell you that. So
You're saying the
the
headset,
headset
the
itself.
hardware.
I mean, with a brand new computer plus a headset, it's around $1,500 from what we.
But for the kind of software that an auto manufacturer would be doing,
Well,
we're
we're
talking
talking
hundreds of thousands.
No. We're talking. It's a software as a service. It'll be a few $1,000s a month, basically.
I see.
Yeah.
There was a question there too.
Mine was price related.
Oh, gotcha.
Can you combine it with those Microsoft glasses, the augmented reality glasses?
Well, that's a very different thing. That's augmented reality. The HoloLens there's no shipment date on that. They haven't discussed when it's going to ship. It works very differently. It's got a very narrow field of view. It's got about a 30-degree field of view, whereas the Oculus has about, or the HTC has about a 110-degree field of view. So it's a very different thing altogether. You're seeing reality and seeing something overlaid versus a complete replacement of that reality. There's applications for both, and actually all the content that we're creating will actually work for that kind of system as well. So we're not too concerned about that at the moment. We'll just wait until it gets here.
Can you elaborate on that a little bit? The difference between augmented reality and virtual. This is pure virtual reality.
That's right.
Augmented reality. If you did the same thing, would there be a car parked in the room?
You could foreseeably do that, yes, but you wouldn't see the whole car at once, right? That's where the field of view comes in. You'll see a 30-degree field of view of that car. So you may see, depending on how far away, you may step way back, you could see the whole car, but as you get closer, you might only see a section of it. But in essence, you should be, other than the fact that that has no computer attached to it, all the processing's done in the eyeglass itself, so you would need to have a much more optimized model. You would see the car sitting on this carpet rather than.
So what's the role, if any, for augmented reality?
I think there's many applications for augmented reality as well. They show a great one on the marketing video. You're talking to a plumber while you're looking at underneath your your sink. You know, I mean, there's a million applications for augmented reality as well. It's a pretty cool potential technology as well. Microsoft's investing a lot of money in that, so it's coming.
Just for information, McLaren has a really good augmented reality example that you can put in your iPad or your phone for the McLaren P1.
Yes, that's a company I founded actually. Yeah. Yeah, that's a company in the UK called I2O3D. I was one of the co-founders of that. Yeah. So I know both sides. I know augmented reality very well, and I know virtual reality. I've got my fingers dipped in both.
Jacob?
Are you worried about how quickly computers and software are progressing, that that computers are progressing in the ability to upgrade, how quickly your software can keep up with it, or any software in general?
No, we just absorb any new processing power, and in fact, our model is such that our software will be sold with the hardware. So you get a box, the headset, software, all ready to go as a kit.
I was wondering the same thing in a way. If the early adopters of this are all going to be gamers, aren't you in essence going to have to compete against the gamers?
There's nobody selling to the enterprise, right? So no one's even thinking about the enterprise. That's all I'm thinking about. So you see the majority, the bulk of the energy that's going out there. It's large companies and film companies and game companies doing this stuff for the mass market. I'm just, I'm a little guy just aiming for something in the enterprise that can become quite valuable as well. So I'm not too worried about that.
I think we have covered the waterfront.
I do want to add, of course, that if I may, that of course applications for marketing cars are just as significant, right? So we're doing it on the design side, but for marketing your vehicle, it's another way to sell it, right? You can give a full dealership experience in the home. You don't have to have them go to a dealer anymore. They can actually feel like they're in the dealer while sitting on their couch.
So used cars, Auto Trader. Is it possible in the future we could see a center where you take your car, it gets scanned, and then you load it onto a used car platform, and people can.
I got my notepad out
can-
for that one.
can
That's actually completely viable.
Finally, go walk around to the right side and see
You
the
know
dent
what?
that you were trying to hide in the photo.
It's not yet, but certainly in 10 years I could see absolutely 100% that'll be the
Why
case.
10?
It's still a challenge to scan shiny stuff, right? So to get it looking really good, it's not. There's bits that don't scan well.
Did that take us to the reflection question?
No, that's a different thing with laser beams and reflective mirrors. Basically, you point a laser at a mirror. How does it know where its thing is in space, right?
And cheating, you take some old.
So the bottom line, folks, is if you have not put on these glasses,
Come try it. Yeah, come give
today,
it a try.
do
yeah.
not leave here.
Yeah.
Look,
Well,
he's on
ready.
his first,
getting first in line. All right, good.
He's got a knife.
Yeah.
Well, yeah,
Yeah, don't bring
he
the
could have
knife
been
up.
last in line, and he would have been first in line. All right, there you got it.
Thank
you very
Thank
much.
you all.
Big hand for our guests.
Thanks very much.